Welcome at Past 25. I'm here. This is the highlights from the mini symposia. I am with Noor Fadel from Swiss National Supercomputing Center of ETH Zurich, who organized the mini symposium addressing scientific and engineering challenges in complex multiphysics coupling scenarios. Noor, can you explain to us what this mini symposium was all about?
It was about mainly complex workflows. Specifically nowadays we have bigger machine with much more powerful GPUs, and this led us to have more complex workflows, and therefore having more complex simulation, and therefore to be close to digital twins, probably in the past you already mentioned. And therefore, there were 3 cases where they explain complex workflow, and they have been, until now, not yet solved. And they present the results. The main case one was geophysical problem, so modeling of an ice sheet in Iceland in this case, but can be applied also on the Alps, on the South Pole. Another case was very important application, was a biomedical application. Basically, the idea was to forecast the toxicity of drugs on the heart. So having the full-scale simulation of heart, so mechanical, electrical, and fluid dynamic, all coupled together. And then changing the parameter at the cell level in order to understand the toxicity of these drugs on the heart, which is a crucial point when a drug company is designing a new drug. And the third one was about analyzing the electric of, for example, of the shield of wires in case of high energy fields. And this mainly, for example, when you have electrical wires, when you are dealing with photovoltaics, that you really need to understand with these high energy fields, how it is behaving these dielectrics in order to design better dielectrics.
So you gave a very exhaustive overview of the discussions, but is there 1 or 2 major highlights from this?
For me,
or take-home messages?
Take-home messages, I would say that in order to tackle these problems, there are 2 ways that we need to go together. One is on, let's say, more HPC side, so moving on toward more powerful GPUs, and in the same time working together, I would say, with mathematicians, with people modeling this, because in this way we can tackle problems that currently are completely unsolvable, and attacking from 2 different sides. So the numerical side, for example, in this case they use what's so-called the reduction model. And on our side, so adding more power and let the scientists to use these new resources, we can really reach the point where we can solve things were not possible to solve until a few years ago.
But then what are the next steps? What do you expect to happen?
I mean, next step, I was able to start new collaboration between the people in the audience. They discovered that they can use other software, for example, for one case, using software GPU-based. On the other hand, other people will say, we can use this reduction model system in order to reduce the complexity in our case. So I would say it was a way to let people discuss together and find new way to solve these problems and apply also to other fields.
So perhaps there are good chance then to see a follow-up mini symposium and the next edition
I
of
would
the
say so.
PASS
I would say
conference.
so.
So
Definitely.
Thank you very much, Noor, for joining us, and thank you all.
Thank you.